So we're going to start off with number 1. If we give you the zeros, remember how we can write the zeros. These are the same thing as the factors. So at some point, the equation came from, if this is x minus 2 as an answer, then that came from x plus 2. So if you think of it, you can add the 2 over to the other side. And then where did the 0 of positive 1 came from? It came from the factor x minus 1. And where did positive 2 came from? It came from the factor of x minus 2. Now the only thing that's different is there's a constant a that we don't know, and the only way we can know that is if we use another point to test this feature, and that's where the Y-intercept comes from. So now they're telling you you have a point at 0, 8, and we're going to plug in 0 for x, and then the output, remember, f y is the same as f of x. That's just function notation. So if this was f of 0, its answer would be 8. I'm going to do it in color. I would get 8, and then we have a times 0 plus 2, 0 minus 1, and 0 minus 2. So we're plugging in the point 0, 8, and then simplifying and solving. So however much work you need to show here, but I've got 2 times negative 1 times negative 2. Well, that's going to give me a positive 4, and then we'll times that by a, and I'll just divide both sides by 4, and I end up with, supposed to be an a is equal to 2. Okay, now we're not done because it does say write the equation. So now we have to take the fact that we know what the standard form was, and factored form I should say. Now we're just going to replace a with 2. So that's what, I believe it was a Delta Math assignment, had to do a couple of those problems from last week. Now, I wasn't sure if we were ready for number 2. It really depended on how your answer came out for number 1. But now that I have this form, if you wanted to, you could expand this out. You could FOIL and multiply all of it out and then get everything in standard form, or we might be able to use just some intuition here. What's the degree? What's the highest x value we're going to possibly have? Well, think of this. I have x to the first power, x to the first power, x to the first power. And if all of those were multiplied together, what degree would we would have x to the third? So our degree would be 3. Because at some point, all of that would multiply out and give me an x to the third. Now let's think about, what about the leading coefficient? Well, the leading coefficient would be multiplying all the leading numbers together. So it's 1x, 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 and 2. Well, 1 times 1 times 1 times 2 is just 2. So my leading coefficient would be a 2. And then what about the constant term? What about that term at the very end? Well, what if I multiply all the numbers that don't have an x? So 2 times negative 1 times negative 2 times the a value. We just have to multiply all those numbers together. So 2 times 2 is 4, times negative 1 is negative 4, times negative 2 is positive 8. Now some people think, you know what, it's easier just to multiply all that out. I might not get that, I might miss something. Well, in that case, just multiply all these terms out, and you'll get a polynomial that starts with 2x to the third and ends with a positive 8. So what about the even or odd function? Well, it's based off of the degree. If the degree is 3, then we're looking at an odd function. And the end behavior, I don't have enough room here, so I'm going to set up that structure. And remember, they could use f of x instead of y. They don't have to have y, they could say f of x. But what we need to do is, I don't have a graph here. However, you know enough information about the degree being odd. So if the degree is odd, one arrow is going to point down and the other one's going to point up. But the question then is, well, which one is up or down? Does the graph look like this? Or does the graph look like this? And that depends on the a value. Notice your a value is positive, which is going to mean it's going to be an increasing function from left to right. So, without a calculator, we knew that this graph is going to look really similar to what I have right here, which tells us our end behavior. Now again, I don't know exactly where this graph is on the x-axis, y-axis. Actually, I do know the y-intercept, but this is a rough sketch, and it's going to allow us to figure out, well, what happens as x goes to the far, far right? My graph is going up. We don't use up as a mathematical term. We say it's going towards positive infinity. And then what happens if I go to the far, far left? So as x gets more and more negative, my graph is pointing down towards negative. All right, so number 3, I want you to factor. And there's one thing that you could do right away that might make your life a little easier. What does every term have in common here? 2. Factor of 2. So that's the first thing that I'm going to do. We'll just pull out a common factor of 2. Which you don't technically need to. I'll show you why I'm going to do that, but so now I've got 4 terms left over. What method do we use if I have 4 terms? Grouping. Right? We try to group. It's not guaranteed to work, but I'm going to group the first 2 pieces and the last 2 pieces and factor those out. So from the first 2 pieces, I can take out an x squared, and what's left over is an x minus 1. From the last 2 pieces, this is where it gets a little tricky, I want to have an x minus 1 left over. So I want this first term to be a positive, so I'm going to take out the negative 4, and what's left over then is x minus 1. Now notice I didn't deal with this 2 yet. Technically, I'll deal with the 2 later on, but it's still there. So then we have the idea that both of my pieces have a factor of x minus 1, and what's left over is the x squared minus 4, and then that 2 can just drop down. We should always ask ourselves, can we factor more? And we do have this one extra piece right here that can be broken down as x minus 2 and x plus 2. And that is in complete factored form. We can't break it down any further. Now, why might I have you do this example? What do you notice about your answer, or your answer to number 3 here? It's the exact same thing as number 1. And that's the part I wanted to kind of bring it around full circle. Wait a minute. Why might we do something like this? I could factor a polynomial. I could call this f of x. And once I factor it, then I can find the zeros. Right? So I can find the zeros Well, where did they come from? They came from the factors. So we kind of went around full circle here. And the other piece I wanted to connect with is, notice the way that this is written. It's probably much easier to answer this question, or number 2, if it was written in standard. So, I just hope that that painted a really good picture of Chapter 5 in general, and how we can go from a standard form to a factored form and make conclusions based off of that. So, what we're going to do is, the nice thing, you don't really have to write much right here. Everything's going to be calculator based. So, if you have your calculator with you or your laptop, I'd like you to pull up your calculator app or your handheld calculator. And we're just going to look at how do we graph some things and what can we determine before we grab our calculator and what can we determine after. And I'll leave this up to you. You do not technically have to write this. I just want you to fine-tune your skills and then see how we could produce a graph given the information that we have. So, let's start with this right here. If I give you a function, we should be able to answer the following questions without a calculator. So let's just kind of do this quick. What is the degree right now? 2. Close. We have to be really careful. Notice how this is in factored form. It's broken down in factors. We definitely have a degree of 2, right? Plus, you can always put a 1 here. And if you were to FOIL everything out, you would get a degree 2 from this part and a degree 1 being multiplied together. So it's actually going to be a degree 3. Now, right away, I hope in your mind you're thinking 1 arrow's up and 1 arrow's down. You're already assuming you kind of know what this graph is going to look like. Let's look at the leading coefficient. The leading coefficient is when you just multiply all the numbers together. So the number's out in front. I get a 1/2. Technically, there's a 1 in front of the x and a 1 in front of this x. So if I multiply those leading terms together, 1 times 1 times negative 1/2, that means I'm going to have a negative 1/2 as a leading coefficient, which tells you have a negative a value. So you now know your graph isn't going to be increasing from left to right. It's going to reflect, so it's going to decrease from left to right. So if I wanted to just kind of draw a rough sketch, I know there's going to be an arrow starting up high. I don't know what's going on in the middle, but then I know it's going to end up down low, which ties into the end behavior. This one we might not be ready for, the number of turning points. It's tied into the degree. And it's not a guarantee every time, it's a possible. So I'll just share this one with you. If your degree is 3, that means you have to turn at least twice to get that odd behavior. 1 arrow up and 1 arrow down. So your number of turning points is just 1 less than the degree. You don't have to worry about that. That's not going to be on the test. I just wanted to throw that out there. But do you know your intercepts from the factored form that we're in? What's one of the intercepts that we have? -3, right? If I put in a -3 here, that's going to make this equal to 0. Perfect. So -3. Now what's another one? Positive 4. Because that'll, if I put a 4 here, that'll make that part 2. So, look at what I can do for my graph then. I can go over -3 and put an intercept and go over 1, 2, 3, 4. So I know where I have to start and where I have to end, and I know which points I have to go through. And then I can find the y-intercept. We have to do a little bit of math in our head. Remember, the y-intercept is whenever x is equal to 0. So what if I plug 0 in here and 0 in here? And then I just simplify. I get a -1/2 times -4 squared times 3. Well, -4 squared is 16. Half of 16 is 8, but we're going to take the opposite of that, so it'll be -8 times 3, which ends up being -4. 24. So I know I would have to change my scale here, probably to go maybe by 3 or 4. If I change it to 3s, I can identify that as just each tick mark is a 3. So then I would go 8 down, and that would put me right here at the y-intercept of negative 24. And then as we mentioned, because of the degree and the leading coefficient, we can determine the end behavior as well, because of the way the arrows are positioned right now. So it doesn't matter if we start with the x going to the negative infinity or positive infinity, you just have to read that carefully. So if x goes to the negative infinity, I'll move to the far left. That's where my graph is headed up. So we would write positive infinity. As x goes to the far right, we're headed towards negative infinity in the y value, because that's where we go down. So all of that without even touching our calculator right now. But that doesn't give me a complete graph, right? It leaves me to assume a couple of things. And we don't want to assume when graphing, so really, what are we actually looking at here? The graphing calculator is going to allow us to find maximums and minimums, and it'll confirm the actual number of turning points. So, let's go ahead and grab your calculator. And go ahead and hit y equals. And we'll type in that function. If you want to use negative 0.5 instead of 1/2, you can. And I'll show you my screen as soon as I enter it in. Alright, so this is what I got. I used negative 0.5 instead of doing 1/2. There are a couple of ways. I'll show you maybe how to use your calculator to get the 1/2 in. If you wanted, you don't have to type what I'm going to, but if you wanted to, you could do negative 1 divided by 2, and that could represent 1/2. Or, this one's kind of interesting. I just learned this a while back. If you do alpha, y equals, it pops up with this notation. If you select option 1, it puts it in the fraction form, so you could get the negative 1/2 that way, which is sometimes really convenient for different things. So, anyways, look at, there's 3 different ways that I can type 1/2 in. I don't care which one you use, just make sure it's a negative 1/2. Okay, I'm going to clear out the first, everything but the first. Now, if we just hit graph, I'm not sure where my window is, and actually my window here is probably not where yours is, so I might do this. This is basically the standard window. It doesn't show me the whole graph. I need to see more in the y direction going down. So what I'm going to do then is hit window, and we're going to scroll down to y minimum. And I know from the work I did before that my y-intercept is at a negative 24, so I want to see past that. I might say, just to be safe, let's go negative 50. Doesn't really matter as long as you're past the y-intercept. So then hit graph. And if that gives you the graph that you need, perfect. But notice how it confirms the end behavior. One arrow up and one arrow down. It shows the function is overall decreasing from left to right because of the negative a value. So now the question is, where is this minimum right here, and where's the maximum? So we're going to go back to second trace, which is the calc function, And remember in chapter 4, we found the vertex. And the vertex was either a max or a min. Well, this is just like finding the vertex. Let's find the minimum first. So what I'm going to do is I need to have the left bound. What I like to think of is I need to bring that flashing cursor kind of where I think the minimum is going to be. And then I hit the left arrow a couple of times. So I just have to be to the left of the minimum and hit enter. And you'll see that kind of dotted line fill in there. And then it says right bound. So I need to kind of go back to roughly where that minimum is, and now I need to be to the right of that spot. You don't have to go far. You could literally do 1 or 2 clicks past. I always do more so students see what I mean when I say we go to the far right and left of those points. When it says take a guess, just hit enter. And there's your minimum. Notice it is not a super friendly answer, and that's going to be the case for a lot of these problems. So I'm going to drag that off to the side, and we'll deal with that in a second. But if I were you, we're not writing this down, but if I was asked you to do this problem, I would write down both the x and y coordinates here. And we always try to round to 3 decimals just to be accurate. So, but there's your x, there's your y for this location. Now I just have to find one more point which looks to be the same as a 0. And you might know that answer because remember that idea of multiplicity? Repeated solutions? We talked about that last week. So you actually probably already know that this answer is going to be a positive 4 because of the x minus 4 squared. But if you didn't, let's just check. Go second, trace. And now we're going to go to the maximum value. And then it's going to ask for the same thing, left bound, right bound, but now I have to make sure I'm doing that with respect to the maximum. So just to show students, I always kind of bring my cursor to where I think the answer is going to be, and then I hit the left arrow a couple of times to get the left bound. And then it says right bound. So I need to go to the right of where I think the maximum is and hit enter. Guess. And I'm so glad this happened. Did you guys get, and you might not, some calculators do it a little differently, but notice how I have that scientific notation here? That means 0. Do not write, if you see the E in there, that means you're going to take this decimal spot and move it 12 spots to the left, which is a very, very tiny number. It's so tiny that we're going to consider it 0. So please be aware that if you see the scientific notation, you understand that that's really saying this is 0. Okay. So if I was doing this, where would my local maximum be? That would be at the spot 4, 0. Where would my local minimum be? That would be at the spot net. And you could convert that to a decimal. You could say negative 2/3 if you wanted, or I would just round it to 3 decimals, and then negative 25.407. Just going to throw these down here, so they're out of the way. The other thing is, let's look at, since we have either graph here, let's look at the number of turning points. Well, how many times does my graph turn from being decreasing to increasing or increasing to decreasing? The number of turning points is how many total maxes and mins do we have? It's 2, which is 1 less than the degree that we started with. So, the last part to create an accurate graph is just plotting the local max and min. The nice thing is my intercept is also the maximum. And then the y, or the minimum, go over negative 2/3 down 25.467. And I don't I can't be accurate there, right? So then I could just write minimum, and if I have the minimum recorded on my paper, then the person reading my graph can look and know exactly where that red point is supposed to be. So, the very last thing then is connect your graph. We know we have to start up high, and again, my estimations for these arrows weren't perfect, right? That's just where we started from. But I do know that I have to start high, go through this intercept, hit the minimum, go through the Y-intercept, hit the maximum, and then end. And that's an accurate enough graph. Okay. All right, one last thing. If you wanted to be more accurate, you can always do this. Go second, table. And here my table set is a little different. Excuse me. Don't worry about this part here. I had my tables going up by 0.5, and I really wanted them to go up by 1s. So if your table's off, you could do this. Go second, table set, which is the window. The table start is where do you want the values to start at. So let's say I wanted to start at -5. That's where the table will start. And then this delta table is the change. So if it's anything other than a 1, if it's a 1, it's going to go up by 1. If it's a 2, it'll go up by 2s. If it's a 5, it'll go up by 5s. So you can always change that if you want. But then go second table, and look at, I start at -5. My x values go up by 1. And here are all the points that if I really wanted to, I could take and plot all of those points on my graph, and that would give me even more accuracy. But notice, it only has whole numbers or friendly numbers. It doesn't have the minimum on there. That's the one graph, the one point that I wouldn't have. So it's important to also know how to use your max and min. All right, I'm going to have you guys try this, and here's. Well, let's look at the degree here. How would we identify the degree? Well, here's the way I think of it. What's the most amount of x's that are being multiplied? We have x to the first power here, and eventually we would get some form of x to the third once that's expanded out. And then, since there's a 1 here, we would have another x. So I'm really taking the degrees of each factor and adding that up. So 1 plus 3 plus 1 would tell me this would be an odd degree of 5. So I'm thinking one arrow is going up, one arrow is going down, and then it's the a value that's going to tell me if it's increasing or decreasing, which is kind of connected to the leading coefficient. So how would I find the leading coefficient? Well, picture this. We're going to take all the numbers that are in front of an x and multiply them out. But we do have to be careful with this one right here, because it's 1 to the third power. If it was a number other than 1, we'd have to be really careful. But it's 1 to the third power is 1. And then here I've got 1 to the first power is 1. So 1 times -2 tells me the leading coefficient is going to be a negative. So that helps me connect with this end behavior idea, that if it's an odd degree and it's a leading coefficient of a negative, then I'm going to start up high and end down low. It's a decreasing function from left to right. The number of turning points is always 1 less than the degree. So we should have 4 different turning points. Now, that doesn't have to be the case, though, and that's where turning points we didn't get into a ton here. So let's look at my x-intercept. Where do I have 0? Well, what's going to make this first factor 0? A 0. And then what's going to make the second factor equal to 0? -2. What's going to make the third factor equal to 0? 1. So I could plot those on my graph. I have a positive 1, a 0, and a -2, and those are my x-intercepts. the y-intercept is whenever x is 0, and we just simplify everything out. Well, this is something interesting. What if x is 0 right here? That's going to make this whole thing 0 times whatever these two turn out to be. It doesn't matter. It's going to be 0. So I know that my y-intercept is also the same as one of my x-intercepts. And then the end behavior tied into the fact that we kind of knew the degree and the leading coefficient being negative. So as x goes to the far right, my function is headed down. As x goes to the far left, my function is headed up. So we use the positive and negative. Now, I'm going to actually show you exactly what Cam was talking about, because if I was just looking to get this done quickly, Desmos would be my best friend. You type it in exactly the way it is, you click on the dots, notice there's the intercepts, and then you just have to read the points. So here's my max, here's my min, and I'm done. So I'm going to use that just because I don't want to spend too much time going over all of this. So this should just kind of give you some feedback as to if you had the right points. So let's just look at the max and min and see if you found those correctly. You should have a maximum at the point 0.632, comma 8481. And then your minimum should be right here at negative 6.32, negative 5.281. And there's a very interesting spot right here. We know that that's an x-intercept, but that's also a flat spot, because I go from a decreasing function and then I keep decreasing. That's not really important right now, but it will be in calculus. So I don't want you to overlook the flat spots. They're still considered a critical point of interest. And then how many turning points do we actually have? Well, we thought we were going to have 4, but my graph only has 2. 2 actual turning points. So that's just something that's kind of unique that came up. Okay, so hopefully the goal here is just to say, you know what, you can use your calculator to help you find maxes and mins, zeros, and can kind of confirm end behavior. Okay. So the nice thing is our test doesn't really have you do much with your calculator, but moving forward, knowing these skills will help you out at all levels of mathematics. All right. So we got about 15 minutes here. I think I'm going to watch my screen just pause. There we go. Hold on one sec. So notice it starts with open-ended, which means this question can have many, many answers. There isn't a specifically one correct answer. But our job is to write a cubic function, a quartic function, and a fifth-degree function who has x-intercepts only at x minus 2, 0, and 4. So I do want you to write this. I'll give you a second. Go ahead and write this down, and then see if you can answer this question. So our our job is to write a cubic function, quartic function, and fifth degree function whose graph has x-intercepts. Well, let's go back to the warm-up. They gave us the, did they give us the intercepts? I'm trying to remember exactly how that was stated. They gave us the zeros. But from the zeros, we were able to write out the factored forms of each one. So, how do we take that information and turn it into cubic, quartic, and fifth degree? Well, let's start with this. If I was to take x equals minus 2 and bring it over, I know that intercept had to come from a factor of x plus 2. And then I know that x equals 0 is a intercept, so that had to come from a factor of just x. And then the 4, if I subtract the 4 over and bring it with the x, here are my factored form. So, the cubic function could be written just like that. And how do I know it's cubic? Look at the degree. A 1, a 1, and a 1 gives me an x to the third. Now, it's open-ended, right? Which means I could pick any a value and I could put any number in front, and that would produce a different answer, a different graph, but it would still meet the conditions of having these x-intercepts and being cubic. So you could put any number in that spot for a, and still be right. So then my question to you is, now that we know how the cubic is set up, what would I have to do to make this a quartic? Quartic is fourth degree, by the way. Make one squared. Perfect. Make one of the factors squared. It doesn't matter which one. I can put the squared here. I can put the squared here, or with the x. But if you look at the degrees, they add up to give me x to the fourth. And now you're starting to see the pattern, right? Doesn't matter what the a value is. So now I need a fifth degree. All you need to do is make sure your exponents add up to 5. Doesn't matter how you get there. You could do a 1, a squared, and a squared. You can do a 1, and a cube. A lot of different options here. Okay. All right. So I wasn't sure how far we would get. I always plan way too much. What I want to show you guys is this. What's our week look like, just so we're all aware? This is on Schoology. If you go to week 6, today we just kind of did some notes with graphing polynomials, and we're going to talk a little bit about the review. And then the homework tonight is a review. The answers are posted in Schoology. Wednesday, we're going to do a Kahoot, and then look at your homework for Wednesday. Get caught up. Turn in any missing work, finish the review, study for the test, because on Friday, we have our Chapter 5 test, and it will be in Schoology. Okay? If you've done well on the last 2 quizzes, you could probably take this test today and do very well. So hopefully that will give you some confidence. I wasn't sure how much time we would have, and we only have a couple minutes, so let's just show you what kind of problems we've covered just to help you out. We've done adding and subtracting polynomials. Okay? The trick with with subtraction is we don't like subtraction. We change it to add, the opposite. That's usually one thing kids kind of forget, so be aware of that. With multiplying, you can FOIL, you can use the area model, or you can use the box method. Box method usually has less errors, so I would recommend that. Then we had synthetic division versus long division. In the review, they're going to ask you to divide. You should practice both. Remember, synthetic division only works when what you're dividing by is a linear function. So if if I was setting this up, we would want to solve this, and we get x equals 4. And then you're going to take the coefficients, assuming there's nothing missing, and drop the 3 down and then start. So you can review your notes on that. Just remember how to do that. Long division was the one that took a lot longer time, right? So make sure you understand how to do both of those. And then we had factoring. And we factored by grouping in the warm-up, so we're not going to talk a lot about that one. Number 2 was sum or difference of cubes. So hopefully you have that pattern written down in your notes. I don't think this is written on the test, but we are assuming you're looking at your notes when you're doing your test, so you should pull that up. Okay? The only trick with this one is we would have to think of how 8 is written differently and how 27 can be written differently. And then we would rewrite, instead of 2 to the third and x to the third, we can say 2x to the third plus 3x to the third. And now, this is in the form where the a value is 2x and the b is 3, and then you plug them right into their pattern. So that's usually the one that students kind of forget about. The last two, think of how you can make your life easier. With this one, the way we want to approach this problem is they all have an x squared in common. And if you can pull that x squared out first, what's left over is something that's easier to factor. And then number 4, this is how I would factor this one. There's 2 terms. What do they each have in common? I think you can pull a 3 out of each one, but you can definitely pull the x squared. So pull something out here and what's left over there. So those are just different ways to factor. So what's going on this week? Today, review of calculator skills, Kahoot. All missing work is due by Friday, so if you're missing a quiz, if you're missing homework, make sure you get that in from this unit. Chapter 5 tests on Friday, and here's the review assignment. The nice thing is the review goes over kind of everything we just talked about.